learning. So we will take another new data set and revise and also summarize the steps of applying linear regression and creating a predictive model. First, I will go to collab.research.google.com in my web browser. This is Chrome, but you can use Firefox, Edge or any other browsers. And I am typing enter, so it will open the file. I am creating here new notebook, and in this new notebook I will give the name as linear regression data 2. Here on top, this I can share with you. So if I change the share settings, then I can share this with you as well. Here I will give the name as linear regression problem 2. As usual, I will import the libraries. I will need pandas, I will need numpy, and from Scikit-learn dot linear model import linear regression. This is my model I will need. Other than that, I may also need train test split, metrics. So I will make a list of libraries that I will need. Pandas, numpy, I will need standard scalar, I will need train test split, I will need matplotlib, seaborn, and I may need mean square error, mean absolute error. I will need R2 score, and I will need grid search. So these libraries I will need for my current data set or current problem. So one by one I will import the libraries. From grid search will come from model selection, grid search CV, R2 score, standard scalar. I will also import a model pickle, because we can save our machine learning model as a file and use it in our deployment also. So here all the required files I have imported. Now for the data set, there are several options. I will pick some data set from seaborn library. Okay, seaborn already I have, so I have my data set as sns.load_dataset, and here I will write penguins, and then I will just visualize the first few columns of the data set. These are the different columns of my data set, depending on species, island, bill length. So this I will convert into X and Y. Let us say I have decided to predict the body mass of the penguins using my linear regression model. So I will first divide my data set into X and Y. This will help me in understanding which is the prediction. So you may ask why I decided body mass, because body mass is a numeric value and linear regression is a regression problem which can predict numeric data. So I could have used any of these as my predictions, but I chose body mass. Remaining features I will take as inputs for my data. So they are in X. I can see there are some missing values. So I can see that there are some missing values in y. How do I find there are missing values? I can take my y train and there is the info. So you can see that 275 entries, but 274 are not null. That means there is one missing value, and same I can apply on y test and ytest.info. So 69 entries and 68 are not null. That means there is one missing value in this y test. So with y drop NA I am deleting that missing value. Now I also have to delete the corresponding row from my x train and x test. So I will create a new variable here, x train, and that will be taken from my old x train, and in this I will only keep those rows that are present in this y train. For example, if suppose my data set is like this, there is row 1, row 2 and row 3, and this is say y train, and here we have some data. The row number 2 has missing data, and x train, let us check how x train is there. X train has multiple features. Maybe row 1 is AB, AAA, and this is BBB. But because we deleted row 2 from y train, the same row 2 from x train also has to be deleted. So for that we can write in this way. That means whatever rows are there in y train, the same rows from x train we have to retain. And that means let us check the shape of all the shape of x train, then x test, y train and y test. We will have to get and make sure that the shape is same. So yes, 274, 274y and 68 and 68. So x train, x test, y train and y test are of the same shape. Next is to where we have deleted all missing values. So just from x train, let us check, are there any missing values? So in x train there is missing value here in the column 6. There are some missing values here. Either I can delete these missing values, or since there are very few missing values, I can delete them, and then the corresponding rows again I have to delete from y train. So these two lines I have to copy. This time I am deleting from x train, and I will write here that I have deleted from x train, and corresponding rows of y train and y test I will have to delete. So for y train, so here the corresponding rows, so whatever now new rows of x train are there after the deletion operation, same will be deleted from y train. And just we can rerun this step, make sure that the data is of the same shape. Yes, it is of the same shape, x and y. So missing values have been deleted, there are no more missing values. Let us check the other problems that occur in x train. x underscore train. So next we see here that after deleting there are some changes more that we should make, especially these three columns: species, island, sex. They have non-numeric data, so we have to convert them into numeric values. So I will write convert non-numeric data into numeric values using one hot encoding. So that is by xtrain get dummies. We can see again xtrain dot head. Now we have changed the columns as species has become species Adelie, species Chintrap, species Gentoo. Island is now island Visco, island Dream, and island, and then the gender. Only thing we can do, though this is okay, we don't have to do anything else after this. We can go for standard scaler. Standard scaling on data set. So here we create an object. Now I can just rename this variable to avoid overwriting. std, and that is now overwriting my that has changed my data. Now it is scaled. If I just write xtrain standard dot box plot, so it will no, it has, it is numpy. Let us see. Create a box plot for the numpy array x train standard and x test standard. We are creating the numpy array for x train and x test. How to do that? Let us click on take help of Gemini and see what suggestions for code they are giving. So here you can see the one suggestion is to convert it into data frame, and then we can take the box plot function of cborn. So we go for that. We take the column names and create box plots for train. Okay, so you can see that mean is 0 and standard deviation is equal. Nearly the data is of the same range. This is exactly what we need before we apply machine learning or linear regression on our data. So here I will write apply grid search CV on linear regression and use parameters positive and fit intercept for grid search. So this is same as what we had done in our previous program. We will apply grid search and then we will train our model and then use the best model after grid search on test. So it is not auto completing, is it? Okay, so positive, true and false, it has created a grid search. There is the grid search CV linear regression. Instead of writing like this, we can create an object of linear regression here. And welcome back to this. So we have now we need the best model after grid search based on some parameters. So we can check here Scikit-learn scoring, metrics and regression. So we have here the scoring methods. This is classification and clustering and then regression. So in regression I prefer this negative mean absolute percentage error. I will write that here, copy and paste, and this link I am giving for reference. Okay, so after the linear regression, whichever is the best model, that will be selected. We have maximum number of iterations. That's it. After that, the best model get the best parameters. So out of these parameters I have written which is the best, and get the best model and apply on test set and print metrics. So this is our next part. Here we are seeing best parameters, best estimator. Further we can create the best model, one variable best model. In this we will have the best estimator. Further we can apply the best model for prediction on the test set standardized, store the prediction here, and then we can calculate the mean squared error. We can calculate the mean absolute error, the R2 score, and the mean absolute percentage error. Okay, so that is not imported. We will import that. Mean absolute percentage error, and we will print that. So we have okay, there is a extra bracket missing here as well as here and here. Okay, so now we can see that best model has intercept true and positive false. It has a R2 score. R2 score is between 0 and 1. R2 score is between 1 to negative infinity, where close to 1 is considered as good. Okay, so this, and the absolute error is just 6%. So it is quite a good model and useful for prediction. So we will continue in the next video what else we can do with this. Thank you.